Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video. Now, by the end of it, you should be able to solve simultaneous equations graphically. There are other ways to solve it algebraically. We'll look at them in subsequent lessons. So, what does it mean by simultaneous equation? Well, simultaneous means at the same time. So what we're going to do here, we're going to take two equations and solve them at the same time. We're going to find one solution that solves both equations at the same time. So we're going to get two equations like this. We're going to find one solution that solves this one, but is also a solution to this one. So if we just look at this equation here, well, it has infinitely many solutions. We're not used to solving equations like this because it has two variables. So for each different value of x, there's a corresponding value of y. So for example, if x equals 0, y would be 3 times 0 plus 1, which is just 1. So this, x equals 0, y equals 1, is a solution to this equation. Because if I substitute x equals 0, y equals 1, I get a true statement. 1 equals 3 times 0 plus 1. That's true. So another solution could be x equals minus 1, y equals minus 2. That would be a solution here. Another solution, x equals 1, y equals 4. That would be a true statement. Because if I substitute y equals 4, x equals 1, I get 4 equals 3 times 1 plus 1. That's a true statement. So rather than writing out the solution like this, I could just write it a little easier. I could write it like this. Remember, when we're writing it as a point, x value always comes first, and we put it in brackets. So this means x equals 0, y equals 1. And similarly, I could write this as minus 1, minus 2, just a more convenient way to write it, and this as 1, 4. So if I turn my attention to this equation here, it also has infinitely many solutions. So a solution to this would be, say, x equals 0, y equals 6. That's a solution, because if I substitute x equals 0, y equals 6, I get a true statement. 6 plus 2 times 0 does equal 6. I could have x equals minus 1, y equals 8. True statement. 8 plus 2 times negative 1 does equal 6. Another example here would be x equals 1, y equals 4. Gives me a true statement. So this has infinitely many solutions, and this has infinitely many solutions. But it turns out there is one solution that will solve this equation and also this equation. And that's the one we just found 1, 4. X equals 1, y equals 4 solves both equations at the same time. None of these other solutions solves both equations. For example, 0, 6 is a solution to this equation, but it's not a solution here. The reason 0, 6 is not a solution to this equation, if I substitute y equals 6 and x equals 0, I get 6 equals 3 times 0 plus 1. That is not a true statement. 0, 6 is a solution to this equation, but not to this equation. As I said, there is only one solution that solves both equations at the same time. So that's what we're looking for when we're solving simultaneous equations. But how do we actually come up with this solution? This time it was kind of like dumb luck for me. I just wrote a few solutions and I happened to stumble upon the solution. Well, one way we can find the solution is by graphing these two lines. It turns out that the graph of the line is just the set of all solutions. What do I mean by that? Let's graph the line y equals 3x plus 1. So you know to graph that, I use the gradient intercept method. So the y-intercept is positive 1 and the gradient is 3. So that means I go across 1 to the right and up 3. So it also goes through this point here. But we also know that it goes through some other points. We know it goes through the point minus 1, minus 2. It goes through this point down here, minus 1, minus 2. In fact, every point on this line is a solution to this equation. These 3 points I've plotted here, they're on the line because they solve this equation. So let's join up these points. And now I have the line y equals 3x plus 1. So this line, as I said, every point along this line is a solution to this equation. Now I can graph this line as well. So because it's written in this form, it's probably easiest to use xy intercept. So if I let y equals 0, I get 2x equals 6, x equals 3. The x-intercept of this line is 3. The y-intercept, if I let x equal 0, I get y equals 6. So the y-intercept is 6. So plot that there. But we also know it goes through some other points. It would go through minus 1, 8, which is up there. It goes through the point 1, 4, which is there. Once again, all of the points on this line are solutions to this equation. Each point has an x value and a y value. And those points on this line, the x value and the y value, satisfy this equation. If I substitute them in, they make this statement true. So joining up, I get this line here, y plus 2x equals 6. So these 2 points intersect here at the point 1, 4. Because this line is all the solutions to this equation, this line is all the solutions to this equation. So where they intersect is at a point that is a solution to both equations. So instead of just using dumb luck, to solve these 2 equations simultaneously, I can just graph this line, and find their point of intersection. Solving 2 simultaneous equations is exactly the same as finding their point of intersection, which I've done here at x equals 1, y equals 4. Remember, that was the one solution that solves both equations. So when you have 2 lines, they will always have one point of intersection unless they're parallel and they don't have any point of intersection and they don't meet. So that's sort of like a special case. But if the 2 lines are not parallel, they will have one point of intersection. That point of intersection is the simultaneous solution. It is the x and y value that solve both equations at the same time. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.